All right, good morning, everybody. Today we are going to be talking about lesson 5.4, which deals with angle relationships in triangles. This does refer to chapter 4, section 3 of your whole textbook called Angle Relationships in Triangles. The first thing that we need to know is the triangle sum theorem, which says that all the three angles of any given triangle must add up to be exactly 180 degrees. Nothing more, nothing less. If the three angles do not equal 180 degrees, then it's simply not a triangle. That triangle cannot exist, cannot physically exist. So given that, although we don't yet know what y equals in this triangle, we do know that if we would add up these three angles, we need to be able to get 180 degrees. So to be able to first find the value of y, we would add up these three expressions. So 3y plus 13 plus 2y plus 2 plus 5y minus 5. We know, although, again, we don't know what y is, we know that this is entirely equal to 180 degrees. The first thing we want to do is combine like terms. So if we add up all of our y's, 3 plus 2 is 5, plus another 5 gives us 10y. And if we add up our constants, 13 plus 2 would give us 15, minus 5 gives us 10. And it's positive 10, so we have plus 10, and we're still equal to 180 degrees. At this point, we have a two-step algebra equation, so the first thing we want to do to isolate y is subtract 10 from both sides of our equation. And what we are left with is 10y equals 170. We can now divide by 10 on both sides to completely isolate our y. And we now know that y equals 17. Now that doesn't tell us what each angle measure is, that just simply tells us what the variable y is. So to determine what each individual angle measure is, you want to substitute 17 in for y in each expression for each angle. So we would have 3 times 17 plus 13. We would have 5 times 17 minus 5. And we would have 2 times 17 plus 2. So you would follow order of operations. So you would first do multiplication to simplify each of these expressions. 3 times 17 is 51, plus 13 means that we have 64 degrees for our top angle. Our bottom right angle is 5 times 17, which is 85, minus 5 degrees leaves us with 80 degrees. And our bottom left angle is 2 times 17, which equals 34. So if you add 2, you get 36 degrees. It's a good idea to always check your math by adding up all of your values. So 36 plus 80 plus 64 does in fact equal 180 exactly. So that's another way to know that we did solve this problem correctly. A side note is that all right triangles, when you have a right triangle, that means one of your angles is 90 degrees. If we think about the fact that all three angles has to add up to 180 degrees, if we remove that 90 degree angle, we are still left with only 90 degrees. So that means the other two angles in that right triangle have to add up to 90 degrees. And it also means that they are acute, because if they have to add up to 90 degrees, each one has to be individually less than 90 degrees. Another side note, another corollary to know is that the measure of each angle in an equiangular triangle, remember equiangular means equal angles, is 60 degrees. Each one is 60 degrees, which makes sense because if you have 180 degrees total and you need to divide it evenly among the three angles, you would get 60 degrees even for each of them. We are given that we have a right triangle, so I can always sketch a picture. And remember, in geometry, it's always a good idea to sketch a picture. We have a right triangle, which means we know that this angle right here is already 90 degrees. We also know that one of the other angles, let's say it's the top angle, is 45 45.2 degrees. So the question is, find the measure of the third angle. Well, we have 180 degrees total in any given triangle. We know that 90 degrees is already taken up by the right angle. So that means we have 90 degrees left to work with. So between 45.2 and something else, our third angle here, we need to create 90 degrees. So what we can do is take 90 degrees minus 45.2. So 90 degrees minus 45.2 degrees leaves us with 35.8 degrees. And again, you can always check your math by adding up all three angle measures and ensuring that you get exactly 180 degrees. So 35.8 degrees plus 45.2 plus our right angle, which is 90, gives us, actually, I did make one slight calculation error, and we all do make mistakes. I'm going to switch colors here. It's not 35.8. Hopefully you guys at home caught my math error there. 90 minus 45.2 is actually 44.8 degrees. I apologize for that error. That does sometimes happen. We are all human. Okay, so now, again, you can catch your mistakes. So 45.2 degrees plus 44.8 plus 90, you should get exactly 180 degrees, which you do in this case, as long as you are using the correct numbers, which we were the second time there. The measure of an exterior angle. So an exterior angle is going to be the angle that is on the outside of the triangle. So the exterior angle for triangle ABC is this angle right here on the right. So angle ACD. That would be an exterior angle to this entire triangle. You basically extend one of the sides and create an angle again on the outside of the triangle. What's important is that that exterior angle is always equal to the sum of the remote interiors. So basically, this outside angle, this exterior angle, is equal to the two angles it doesn't touch added up. So for example, 84 plus 16 is 100 degrees. So 84 plus 16, 84 degrees plus 16 degrees equals 100 degrees. What that means is that angle ACD is actually 100 degrees. So right here, this question is, what is the measure of angle ACD? Well, it's 100 degrees. And the reason that we know that is because even though we originally wrote it as 2x plus 20, it is the same thing as the sum of this angle here, angle A, and angle B, because those are the remote interior, meaning the interior angles of the triangle that do not touch this exterior angle. To solve for x, well, we know that 2x plus 20 is equal to the sum of remote interiors, which is 100. So we can say 2x plus 20 equals 100. So solving for x, we would subtract 20 from both sides. And then this leaves us with 2x equals 80. And if we divide by 2 on both sides, x equals 40. And so that would be the value of x, which is the first question. What is the value of x? X is 40. If we substitute 40 in for x, 2 times x, which would be 2 times 40, which is 80, plus 20 gives us 100. Our last question is, what is the angle of ACB? So that question is, what is the measure of the third interior angle? So if I switch colors here, what is the measure of this angle? And some of you at home may already say, well, you know what? We know that it has to be 80. And here's why. Because we already have 100 degrees, and we need 80 degrees to get 180 degrees. The two reasons we need a goal of 180 is because the three angles have to add up to 180. Or if you think of this as a straight line, this angle plus the angle on the left need to be 180 degrees. So no matter how you look at it, the angle sum or a linear pair, we know that 100 plus something needs to be 180. So that means our something is 80 degrees. And last but not least, we have the third angle theorem. So if we have two triangles, and we have two angles in one triangle matching up to the two angles of another triangle. So for example, we may have two randomly given triangles. If this angle is 30 degrees and this angle is 30 degrees, we also have another angle being 60 degrees and this angle being 60 degrees. So if you can match up two angles between two triangles, that means those third angles are going to have to match as well. So if you do the math, that means these third angles will automatically have to be 90 degrees. Looking at our picture here, they tell us these two red lines right here means that angle A and angle D are congruent. So there's one of our angles that we need. The single mark here means that angle B and angle E are congruent. So we have two angles in our first triangle that match up with two angles in our second triangle. That means that our third angles here, C and F, they have to be congruent, which means they are equal to each other. So given that, we can set them equal to each other. We can say 4x squared equals 3x squared plus 25. So if we want all of our x's on the left-hand side, we're going to subtract 3x from both sides. 3x squared minus 3x squared. So we are left with x squared equals 25. And so what that produces is we would take the square root of both sides. So what times itself gives us 25? That would be x equals 5. Given that information, we can then calculate the value of each of these angles. So DFE is going to be 3 times 5 squared plus 25. So 5 squared is 25 times 3 is 75 plus 25 is 100 degrees, which we should get the same answer on the left. So 4 times 5 squared. So we first square 5, 25, and 25 times 4 is 100 degrees as well. And that would be how you can use the third angle theorem to find the third angle between two triangles. Thanks for joining me today, guys, and I hope that you have a wonderful day.